don't. Bode. I listened to that album all the way through it, and it's pretty good. You have good taste. And there's one song that I didn't realize that I had already heard. I can't remember how it even goes now. Frickin' it was pretty like maybe reborn. Well, you know, that's a good question. To be honest, that first one just go ga 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 ga. Like it really sticks in my head. Like even though it's weird, I kind of like like it. That's a good question though. I unironically may have been that. If not, then I think Fourth Dimension. I'm looking at the song list again now. So I like how they got the Louis Prima like in there too. Yeah. Sample's very cool. Yeah. Okay. So for the downtime activity for today, a while back, Dr. Cook sent me these calculus problems that he had made. I don't really know for what purpose, but he has them. So I want to try them. So this is the easier problem set. You just call them like bonus problems. There's 4 pages worth. 10 problems that, wow, that 10th one is pretty long. Goes into the Laplace transforms. Oh, okay, that's a basic one. The gamma function. Different. Oh, it's this Feynman? Oh my god, he does Feynman in the easier problem set. Okay. Now I'm scared. And half derivatives? I saw it. I'm sorry, hard luck. No, I'm scared. I'm about to go to the word though. If you had just like waited. You'll be back later, still creating problem sets? All right. Good luck, Joseph. Thanks for saying hi. So I didn't find it without using L'Hopital's, do that limit, and okay, that's a neat. I usually do the same thing in a different way, but I want to do it the way the hint says. Oh, come on. 1 second. My cord is stuck. There we go. So we have one where x is going to, oh, x is going to 0, not infinity. That's good to know. Okay. So normally what I would do here is I would multiply by the thing with the square root, but change that to a plus over itself. But I think the hint that Dr. Cook said accomplishes the same thing in a different way, where x squared is the same thing as 1 minus x squared. And this we could think of as a difference of 2 squares. So we should get 1, I think, but a factor to 1 minus x squared, 1 plus, oops. So we get a cancellation, is the important part. Oh, I guess we get 2. Or 1/2, ugh. There we go. Okay. Nice little problem there. Oh, wait. This one doesn't even... When choosing this function f of x... Yeah, I mean, this is gonna be the same idea. X is going to infinity this time. Root x squared plus 2x minus x. So now I will do the way that I said, where we just change that to a plus. X squared plus 2x plus x. Or root x squared plus 2x plus x. So we get the limit as x goes to infinity. All right, so we have to do some foiling here, but so that times that is the square root of itself, so it's just x squared plus 2x. The middle terms cancel, we get minus x squared. I explained that horribly, but you know, who cares? I'm doing this for fun. Okay, so the x squared's on top, subtract out. It's the only cancellation I see. It's probably okay though. Yeah, it's definitely okay. Because as this goes to infinity, we can now do a little trick here. So the degree on top is 1, the degree on the bottom is basically 1 because we have a squared under a square root, so that becomes 1. The leading coefficient trick is kind of weird though, because we have two things that are of order 1. Would it be 1 plus 1? Let's actually try and like show it. Should I do it this way? Sure. Multiply by 1 over x over 1 over x. Get 2 on top. 1 over x root x squared plus 2x plus 1. And then we need to bring this 1 over x inside the root. And 1 over x is equal to root 1 over the square root of 1 over x squared. That's how we're going to do that. So we can basically make this the square root of 1 over x squared, and since they both have a square root, we can multiply them together. So we get 1 plus 2 over x plus 1. Now we can just plug in infinity, so that term becomes 0. Oops, no more limit, we're evaluating it. So we get 2 over 1 plus 1 is 2. So 1. Okay. No, so that's interesting. We did not add those coefficients. Oh, wait, yes, we did add the coefficients. I just don't know how to add. Hey, Jed. Oh, shoot, I'm behind on YouTube chat. Sorry, I didn't see that. Jed, order 1 plus order 1 is still order 1, correct? Can we approach both these problems using sandwich theorem or find some epsilon for which it works? Can you try to solve using those methods? Why would you when there's this much easier way of doing it? I'm definitely not doing an epsilon delta proof of this. I barely know how those work. If you wanted to sandwich it, there's probably a sandwich to be had here. I mean, in theory, there's always a sandwich to be had, right? But What would be a good sandwich for the first one? The result is 1/2, really? Why was I thinking it should be 0? I mean, I'm about to use a proof by Desmos here, Jed. Oh, it's like a smiley face without the eyes. But that's one that that's on the top portion of the board. You have to use the little trick that's explained in the hint. It's not too bad of a limit if you know the trick, but it's impossible if you don't. I really don't know what you would sandwich this with. There probably is one. I just don't know what it is, though. Do you know anything about the Bernoulli numbers? That sounds vaguely familiar. Maybe I'm thinking of the Bernoulli distribution. Oh, hey, this link is purple. I've Googled this thing before. Oh. I remember oh, yeah, it's probably because of the Riemann zeta function that I came here. No, I don't know anything about these really. Wow. Wait, so Jacob Bernoulli and this dude's name I won't try to pronounce independently discovered it within a year of each other? Oh wait, no. The Japanese person, that was posthumously published in 1712. So he discovered it way before Bernoulli did. Of course, Bernoulli gets the credit though. Huh. But yeah, sorry, I had never really looked at these seriously before. Let's verify the second limit down here. We need to, in general, more serious stuff as well. Yeah, I mean, I'm wondering if it's possible if they'll come up with Zach's series course. Labs Con. I used to watch your lives during my GCSEs. I'm doing maths at A level now. You got all A+ in your GCSEs? Nice! Congrats. Thanks for watching, too. Okay, so I got 1 for that limit, and it does look like the limit's 1. Okay. Okay, there's only some construction that's happening outside my house right now. Just I just want to go and look at it quick, because I'm a curious George. Oh, it's literally, oh my god, there's an entire cement mixer in front of my house. What are they doing besides mixing cement? I don't know. Okay, fine. I'm back. We don't hear the sounds? Oh, good. That's good to know. Next course, my school is stacked. 3 math courses, 2 physics at the same time. Oh, dang. Yeah, that's a lot. You got an 18 out of 64 in your test. Oh, in a test today, Ishan? Oh, I'm sorry. That sucks. Taking up with that body in the basement? True, Jed. Really been procrastinating on, disposing of that body. Bode's asking what test? I didn't see Ishan say, but sent the questions on Discord. Oh, this was the test? I'll look at it. I don't see any, like, your name isn't on this or anything like that. So yeah, I'll show it. Yeah, speaking of Bernoulli, that next one. Oh, what the hell? Oh, you can factor that, I guess. No, you can't. No, it's not cleanly. Uh... This isn't like a test for your school? No, I was looking at number one. You can mess around with it, but I don't see a way to easily simplify it. Basically, learn theory and no beauty. Three z minus 2z equals 1z. Well, why is there a z on the right side? Oh, wait. Oh, I see what you mean. No, no, no. That's 3z squared. Yeah, yeah. Yeah, this is kind of terrible, dude. Like, I would not do well on this test without doing some really specific studying. If I were to just take it now, like, I would do pretty terrible. It was f of x equals x. Yeah, that hint doesn't help me personally. It probably does help, but non-negative integral solutions. I think it's another word for integer. I don't know. Or I don't know what an integral solution is. Or 6. Integer is same as integral. Okay. 2 hours for this test. It's not happening for me for sure. Integer is not the same? Oh. I feel like I've Googled this before, but I don't remember what it said. A right continuous function having left limits. That's a new concept for me. Like, what's an example? A right continuous function. If it is defined on an interval CD lying to the right of C. I need to see a picture. Are you going to give me the definition without a picture? Oh my god, who made this slide deck? Critical, I got back to your questions, didn't I? Different ones? Oh, okay. Sure. Is it seriously that hard to just show me a picture? In my Discord in general. Floor of X is a right? Okay. Like, actually, Desmos isn't really the best thing to draw this in because they don't do the open circles. But doesn't the left-hand limit also exist? That's why I'm confused about like a step function like this. Because I saw you drew a step function here. I don't know if that was yours or the teachers, but I don't know. Oh, because the left limit doesn't equal the function value. Okay, I get it. Because of the open circle, where the limit is doesn't equal the value of the function. Okay. I'm on board with that now then. Would a calculator even help here? I don't think it would for most of these questions. I guess the first one it would help. All the other ones though, I don't know. Maybe the third one, you could kind of graph that limit. For the third one, like number, oh, or maybe that third one. There's three. Yeah, there's two threes. What are the problems? All right. Wait, E is on AB, F is on BC. Oh God, okay. Yeah, I'm gonna look at critical questions. That, well, I mean, it kind of sucks that you have to do that. Those aren't easy problems. So we have a vector function here, and we want to find the arc length. This should just be a formula we can plug into. I gotta go to trusty Paul here. Tests for high schoolers? Yeah, that's stupid, dude. You shouldn't have to do that. Yeah, I don't think you should ever have to do problems like this. Like if they have a use, I certainly don't know what it is. Where? What am I looking for here? It's not in the calculus 2, right? Maybe it's in vectors. No, they don't do any calculus with vectors there, do they? Might be in parametric. Yeah, I guess it's parametric. Basically made for some obscure theorem or some obscure method. Yeah, bud. It's an Olympiad tutor thingy. Okay, so that's not like what high schools normally have to do then? It should be this formula, but we have a third term with plus dz dt squared. Does that sound right? Critical? That it looks like this, but with a dz dt squared also in there? Yes? Okay. So I could go and Google it, but if that's the formula that you're using, I think I'm sure it's right. Last one, ln cosine t. Okay. Okay, so cosine t, dx dt is going to become minus sine t. dy dt is going to be cosine t. dz dt is going to be 1 over cosine t times minus sine t, which is minus tangent t. So the arc length, L, is going to be, the bounds they give us are 0 to pi over 4. Square root dx dt squared plus dy dt squared plus dz dt squared dt. Okay. This integral looks hard, but it's going to simplify nicely. We get, let's just start by squaring everything. All right, so what we have to notice here is that sine squared plus cosine squared is 1, Pythagorean identity. Then if we use our other Pythagorean theorem, Pythagorean identity, this is secant squared. Square root of secant squared is secant. Now, secant is annoying to integrate. I forget. It's something that you can also just, like, that's one of those ones that I would just Google it. Yeah, it is 1 over cosine. I don't know if that's going to help us here. If we want to actually show it, I assume we do it with integration by parts. Is there anything else that we could do? There might be a sneaky u sub. We should get ln. It's ln secant x plus tangent x, if I have it memorized right. How would we get that? Yeah, punching. It's something like that. I'm trying to figure out if we should actually prove that or not. Takshio says, or do by parts multiplying with 1. Okay. Yeah, let's try the integration by parts way. So critical, you probably don't like, I don't think I was expected to do this integral in my calculus class. You could validly just have it memorized, or hopefully you have a table or something like that you can look it up in. But if you do have to show it, I think the best try is to do integration by parts and remembering that there's like an invisible 1 times that. So I'm going to say that u is secant t and dv is equal to that 1 dt. So du is secant t tangent t. This is confusing, so I'll put parentheses, and v equals t. So after integrating by parts, we get u v v du. T, this won't be right, I don't think. No. I don't think integration by parts is right. There's a different way that we can do this. Yeah, if we could just use the result, that'd be nicer. It's going to kind of bother me if I don't know what the first step is for this integral. So let me just... Oh, all right. Fuck off with that. You have to spot that. You want to know how ln tangent becomes square root 2? Probably because of plugging the bounds. Integral of secant. You want to know how the tangent becomes square root 2? It doesn't. The secant of 0... Wait. Tangent of 0 is 1. Secant of 0... That's root 2? It shouldn't be, right? Cosine of 0 is 1, and 1 over 1 is 1. Wait, yeah, what? Why is there a root 2? Oh wait, pi over 4, 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 pi over 4. Wait, tangent of 0 is undefined, isn't it? No, it's not. It's 0. Tangent of 0 is 0, right. Okay. Sorry, I wasn't reading this work right. I thought that was an equal sign, not a minus sign. This root 2 is secant pi over 4. Oh my god, bro. Just, oh my god. Okay, fine, we're using this. So what you do, secant is 1 over cosine. So look up what cosine pi over 4 is on the unit circle. Pi over 4 is right here. The x value is root 2 over 2. Root 2 over 2 is the same as 1 over root 2. And so when you flip that for secant, you get just root 2. I'll show that because I said a lot of words there. Secant of pi over 4 is equal to 1 over cosine of pi over 4. Cosine pi over 4 is 1 over root 2. So when you have 1 over root 2, you get just root 2. And if you've got the unit, and I'm making a little switch here, 1 over root 2 is the same thing as root 2 over 2. And it's a little bit easier if we use this version rather than the root 2 over 2 that the unit circle normally has. Hey, $10. So does that clear up your question, critical? Yeah, it's the arc length. Yeah, they're the same thing. And so I just use 1 over square root of 2 because it's a little bit easier to flip. You could also have done it with root 2 over 2. It's just a little bit extra work. How to reverse it? What do, like, by reverse it, do you mean, like, how do you deal with 1 over root 2? Like that fraction of a fraction? Is that what you're asking about? Oh, like that, yeah. So maybe that was a bad idea to explain it like that. How this usually comes up is you end up with getting 1 over root 2 as the answer to a problem, but for whatever reason, people don't like irrational numbers in the denominator, so you do what's called rationalizing the denominator. So you take this and you multiply it by square root 2 over square root 2. Because we get square root 2 on top, and root 2 times root 2 is just 2. So these two things are exactly the same because we just multiplied by 1. we could have also done 1 over root 2 over 2, which is 2 over root 2, and now done the same, rationalizing the denominator. So we get 2 root 2 over 2, and the 2's cancel, and we end up with the same answer. It's a little bit of extra work, but if you're not comfortable with doing like 1 over root 2, then just do it the way that you're comfortable with. Hey, Abhinav. No, I'm sorry, JE Advanced is a little too hard for me. You have time to try to jump because you're late by 20 minutes? Oh no. Your tag thingy? I don't know what that means. Yeah. So were you stuck on a specific step on the next problem, or are you? Or like a curvature? I think that's making it needlessly complicated to explain it like that, Jed. Its complication is your middle name. Have I ever solved J mains math questions? Maybe, but I probably struggled a lot with it. And I'm definitely not solving an entire paper. That would take way too long, and I don't know the tricks that they use. I don't really enjoy solving those problems, to be honest. Jed needs complication, Levi. Curvature. Curvature of a vector function. Oh, this is, Paul does talk about this. Where, though? Okay, fine. Here we go. Yeah, bust your kappas out. So there's a couple different formulas for it. Today's my physics exam? Oh god, I'm sorry, but like, I hardly know physics either. I'm best with like calculus and like the stuff that you would normally encounter, at least in like an American like curriculum for like calculus and below. So critical, are you stuck on a certain part of this problem? Or like, what's your question about this one? Here you go, Jed. Kappa clause. I don't think I've ever seen that one before. You can solve it till the end. I've never seen that one either. Is that like a wealth of those little coins, I guess? Okay. Um, so right here in the upper right corner, you don't know how to get this step. Oh, okay, yeah, I see it. But yeah, so critically, you're asking about the top line, right? Or you're asking about the bottom line? Because I'm still not sure if I... Top? Okay. Okay, I see, yeah. So you can get to this equality in the middle, but you don't want to get from this one in the middle to this one on the end. Okay, let's do it. Okay. So we have 2t minus 2e to the t squared, 2t minus 2e to the t squared plus minus e to the t squared plus 2 squared. Okay. First step, let's, okay. First step, let's deal with the squares. So we have two things multiplied, squared, so we can distribute it in the squared. So we have 2t minus 2 squared. E to the t squared is e to the 2t because the powers multiply. Plus, the negative goes away because we're squaring it, and then we do the same power rule. T times 2 is 2t, then 2 squared is just 4. Now look at these two terms on the left and see they both have e to the t, and let's just factor that out. Plus 1 e to the 2t plus 4. So, oops, squared. All I did is I took these two terms and I factored out e to the 2t. So we have the 2t minus 2 squared and then a plus 1 for that term right there. Now let's multiply out this 2t minus 2 squared. Or t, really? I did that wrong, didn't I? I can't have. That should be 8 in the middle, right? Yeah. Okay, right. So then we just do 4 plus 1 is 5, e to the 2t plus 4. And I think that's the exact step that they leave off on. Yeah. Hey, Jamal, feel free to put it in chat there, or you can put it in my Discord. Sounds good, Jamal. And I'm sorry, but you're asking about things I just really don't know about. Like when it comes to studying math in general, I can say that it takes a lot of practice and repetition, but I have no experience doing JE anything. Can I do the entire problem? Oh gosh, Jamal, now that we're is that a competition question? So if it's competition, I almost certainly can't do it. Oh god, this is just a lot of work. Should be fairly... I've had people say that before, and it turns out to be a competition problem that I have no idea how to do. So, I'll copy this over to Twitch chat. But when I see all these orthocentric triangles happening, I get nervous that I can't do it because it's not a competition problem, but I see like cyclic quadrilateral as well. I'm gonna try and work through this other problem first, Jamal, but I'll try to take a better look at it after this. Oh, that's right. That's what cyclic means, yeah. That's just inscribed in a circle. All right, so we need to find the t, which is we take the derivative and get the unit vector. So critical, this is a pretty long problem. I'm gonna do a lot of things mentally here. It's gonna take a little too long to show every step here. Yeah, if someone does have an idea for Jamal's geometry problem, like, feel free to put it in there and I'll pass it along, but I'm gonna try and get through this one first before I take a harder look at it. All right, first step is to find the unit tangent vector. So we take the derivative and make it a unit vector. So let's first start by finding r prime t. Plus e to the tk. Now the magnitude of r prime t is square root 1 squared plus 2t squared plus e to the t squared 1 plus 4t squared plus e to the 2t. So then the unit tangent vector is I plus 2tj plus e to the tk divided by the magnitude 1 plus 4t squared plus e to the 2t. Now that we're over kappa, we need to take the derivative of t and make that a unit vector again. Oh God. They seriously want us to do 3 quotient rules? I guess we can do the other r prime t cross r double prime t. Maybe that version of the formula is just gonna be too hard to use here. If we do r double prime, we get 2j plus e to the tk. Himuel Peñas Pangilinan? There's only 1 minus 2 plus 1 minus 3. 1 minus 2 plus 1 minus 3. Just go left to right here. So 1 minus 2 is -1, plus 1 minus 3. -1 plus 1 is 0, minus 3. 0 minus 3 is just -3. Yeah, the cross product might be easier. So I need to take my r prime, my r double prime, and cross them. Then make it a unit, and then find the magnitude. To t to the t, 0 to e to the t. Zero e to the t, e to the t. J 1 2 t 0 2 k. 2I e to the tj. Why do I have a? I did this wrong. I had a 0 in all of them. That wasn't right. Blocked off the wrong column for I. That looks better. I need to find their magnitude. Uh, 2t e to the t minus 2e to the t squared minus, plus minus e to the t squared plus 2 squared. And that looks familiar. I'll look at that in a second, Basil. Oh gosh, that looks very specific. I'll take a look at it, and I have to do this problem, then another problem, then I can look at that more. Okay. The curvature is, that's a terrible kappa, but 2t minus 2e to the t squared plus minus e to the t squared plus 2 squared over r prime t magnitude cubed. So this thing cubed. You keep a square, you get a power 3 over 2. Well, yeah, so from where I left off, we need to do what I showed you at first, which is, well, I need to factor out the e to the t to make it match exactly, but you just do the same thing that I showed you with factoring these e to the t's out and then squaring. Can you go back into the VOD and screenshot where I showed that? I have 2 other questions that I need to look at critical. Thank you. Anyways, where there should be fairly easy, complex number seems like the easiest approach, the most natural one. Okay, after seeing the discussion about that geometry problem from Jamal, I feel more inclined to just Google it because I don't think I'm able to solve it for myself if those two can't do it with the normal geometry that I'm familiar with. It is complex numbers. Yeah, I've never used them for geometry problems. I don't know how it works. I don't know what this means, to be honest. Yeah, sorry, Jamal, but that geometry problem is just beyond me. Okay, so Basil put a small essay in the Twitch chat. I'm sorry, YouTube chat. I hope you are doing well. I am writing to seek clarification on a concept related to the Hardy-Weinberg equilibrium model, particularly concerning degrees of freedom using chi-square analysis. It is often known that the degree of freedom is considered to be equal to 1 when using chi-square analysis. Despite the presence of 3 genotypic categories, homozygous dominant, heterozygous, and homozygous recessive. So here's the question whether the degrees of freedom is not df equals n minus 1, but rather number of genotypes minus number of alleles. Explain why this disparity exists and clarify the degrees of freedom is calculated based on the number of genotypes. I definitely don't know the answer to that offhand, but I do remember learning about chi-square. Equilibrium model. Let's see if we can find a resource about this. I remember being taught if you have a table of values when you're doing chi-square, it's like number of rows minus 1 times number of columns minus 1. And if you only have one row or one column, then you just count that as 1. Oh, true, Bode, yeah. Jamal, if you do have Discord, there's a Math Olympiad Discord where they might be able to help you out. Thank you for the reminder on that, Bode. I'm in the Discord too, but I hardly look at it because it's a scary place. Like, geometry questions that are that hard, or just in general, like competition problems. So maybe the question is, why don't we have 2 degrees of freedom here, like a normal chi-square? And when using this model, we apparently just consider us as having 1 degree of freedom. Seems like a reasonable question. It's generally used, okay. Degrees of freedom equals 1 is generally used for HW even when there are 3 phenotypes because the expected can be calculated starting with one of the 2 alleles. Oh, so maybe there's a dependency between these 2? So they're not truly different things. I see there's an asterisk. I want to see where that note is. Degrees of freedom can get confusing here. Keep in mind that it is unlikely that an AP biology question will be dependent on differentiation between 1 and 2 degrees of freedom in this context. It is all not AP stats. Now the question prompted this post to ask for the chi-square value only. One last pizza and the longest one. Stay strong, Joseph. So, Basil, I'm not really familiar with the biology part of this, but at least from what this website is saying, it seems like two of these alleles are dependent on each other in some way, and they're not like truly that different of a thing. Which is, I'm a little bit confused by, but I assume that's just me not knowing the, like, I know next to nothing about biology, so. That makes sense? Okay. All right, I'm glad I was able to actually help with that question, because I'm reading, I was a little bit scared that I just wouldn't get it, but that's always my guess at why you would only use 1 degree of freedom there. Getting rid of that. Do it a bit later, can't keep up with this adrenaline rush of being almost done with your problems. If one of those frequency 50%, the other one would also have 50% dependent on the first frequency. Oh, okay. Interesting. Let's check out the Discord. Oh, okay. Here's the concept of a security proof, which is used to validate things in security in things like cryptography or other security protocols. Seems very like a simplistic proof, but I don't have much experience with this or helping folks out. Oh, yeah, I certainly don't. They're complementary proportions. Oh, okay, yeah, that makes sense then. All right, so I guess things have slowed down again. Let's maybe go back to doing the setting that we were doing at the start of the stream. Just working off some forum threads as answered. So we were just going through these calculus problems for fun. We've done problems 1 and 2, and I was starting to look at number 3. All right, so Jacob Bernoulli first discovered the mathematical constant E by studying compound interest. He realized that if an account starts with $1 and pays, say, 100% interest per year, put a lot more than $1 in there if that was the case, but the end of the year value is $2. So compute it and add it twice in the year. $1 value is multiplied by 1.5 twice, yielding $1 times 1.5 squared equals 225. Compounding quarterly yields $1 times 1.25 to the fourth equals 2.4414. Something to consider that limit. I'm trying to draw the direct line between this limit and this compounding process here. It's because if you compound twice yearly, n is 2, and you have a 3 over 2. So, right, this is just getting the interest part, and then you can always multiply your starting value in later. So yeah, if you were blocked. That works on YouTube too, right? All right, so let's look at part 1. That should be a pretty quick one. This problem is it's a little bit too thick to fit on the screen at once. We can cut off the intro text, I guess. Rigged. Don diligently finishing all his pieces while crying from stress due to the sheer amount of pieces due every week. It's too big to fit on the screen. Yeah, actually, this is still too big. It's most definitely what she said. Let's see that drawing though. Okay. I didn't see it, but I was sort of expecting it. Ugh, thank you, hard luck. I didn't have to look to see who that was. One day you'll get me with that. Like you'll get me good. Okay, me diligently finishing all my P sets while crying from stress to the sheer amount of P sets to do every week. A table, a chair, I this is I don't know, dude. This drawing is already going terrible. Also, I'm built like Marilyn Manson. Don't worry about it though. I also have very long extendo arms. All right, that was a little better. Thank you again, hard luck. Oh yeah, I just remembered. You look like one of the teaching fellows in my intro mechanics class. You both have the same beard style and stuff. Well, he sounds like a good looking dude, I gotta say. You know, if he looks like me. Big old nerd glasses. Wait, how do you draw sad? How do you draw a sad face? Like, that's sad. Okay, yeah. The eyebrows have to go that way. Teardrops. Look a little bit like sweat, but there's probably also some sweat in there too. My hands are the same color as the table, don't worry about it. Also, my hair is the same color too. That looks terrible. And then it's gonna be, I guess you need a pencil. Gonna be like littered around the floor too. One like hanging off. That one's not even a rectangle, dude. This is getting really fucked up. You know things are going bad when your paper stops even being a rectangle. All right. How's that? Oh, let me catch up on chat here. Hey, Daniel Bordiano? Papers on the floor are so accurate. Look at what Basil's saying. Description. A species has a population that grows according to a logistic model. The environment can support a maximum population size of 5,000 individuals, known as the carrying capacity. The initial population is 100 individuals, and the growth rate is 0.1 per year. Population starts growing at this rate, but slows as it reaches carrying capacity. Calculate the population of the species after 10 years, given the carrying capacity is 100, the growth rate is 0.1 per year, and model the growth function. So this sounds like a differential equation, but I don't know if you would Like as a math student, I have to make a differential equation and solve it. But I wonder if as a biology student, you can just use a formula? Logistic population growth model. Okay, yeah. This looks familiar here. Biostats ew. Dude, mathematical biology is actually kind of sick. Disagree there. What is not sick is they didn't even use the wrong version of there. They just didn't. That's the there that you use if you don't know which there is correct. So you just misspell it. um. Okay, the population y is proportional to the product of the current population y and k minus y. Or what is the same thing? Proportion to the product y times 1 minus y over k. Okay. I guess? Team computational biology for like 5+ years, so I'm trying to run away from it. Oh, that's fair. Okay, sure. So, Basil, are you... Like, do you know what a differential equation is? Are you expected to make a differential equation and solve it? Or are you able to use, like, the end result formula here, which looks something like this? Let me zoom in. Because here, K is the carrying capacity, R is the rate, which is 0.1. And A may not exactly be the starting population, but it's going to depend on it. It probably will just be 100, but I would want to check that. Actually, it might not be 100. Okay, I'm not seeing anything from you, Basil, so I might... Oh, okay. It was expected that we graph the function using a graphing calculator that we use that graph to find the population size after 10 years. Okay, so then I'm going to assume that you're not doing differential equations here. So I'm just going to jump straight to using this formula here and plugging things in. And I hope that this formula looks familiar to you, even if things are named a little bit differently. But if this doesn't look familiar to you, then there's an issue and I looked up the wrong thing, I guess. So the population, the formula that calls it y, but you might also call this p or something. is equal to K, the carrying capacity, over 1 plus A e to the minus RT. Rate, and then constant. Solve for it. Okay. So we need to figure out what A is, and A is going to depend on what the initial population is. Actually, well, first let's plug in the things that we do know. K, we said, is 5,000. One plus A e to the minus, we said R is 0.1, and then times T. So now we need to use, we know that y equals this. We also know that y of 0 is 100. That means at time 0, our population is 100. That's the initial condition that they gave us. So let's plug this information in up here to solve for A. So y of 0 is 100, so 100 is equal to 5,000 over 1 plus A e to the minus 0.1 times T is 0. Okay, so let's start cleaning things up. Let's not write the wrong number. So first things first, e to the, well, 0.1 times 0 is 0. Negative 0 is still 0. So this is just e to the 0. And anything to the power of 0 is 1. So a times 1 is just a. So we can just kind of get rid of the e entirely here. Now, keep on solving this for a. Let's divide the 5,000 over. It doesn't matter. There's a couple different ways you can do this, but I'm going to start by dividing 5,000 to this side. 100 divided by 5,000 is 1 over 5. 50, right? Yeah, it's 1 over 50 equals 1 over 1 plus a. Holy crap, Hardlocked. Subscribed at tier 2 for 6 months in advance? Thank you so much, dude. Holy crap. You plan ahead, let me tell you. I really appreciate that. I feel bad after like the jump scares keep not getting me, but thank you. Plus you're already at 12 months too. That's crazy. Okay, what we can do here, we can flip each side. So 50 is equal to 1 plus a. Subtract the 1 over, get 49 equals a. Okay, so we don't get exactly 100 for a, like I thought, was maybe possible. But A represents our initial population. Oh, but yeah, if you plug in 49 for A at 0, you would get 100. Okay, so yeah. It does represent the initial population, just a little bit indirectly. So we have our function that we can graph now. And you're saying that we graph the function using a graphing calculator and that we use the graph to find the population size after 10 years. So let's do that piece of it. So I'm going to use Desmos, but you can do the same thing in a graphing calculator that we're doing here. I mean, you don't even necessarily need to graph it. You can just plug in 10 for the time. Where am I? Here I am. In Desmos, I'm just going to put a bar at x equals 10 and look for where the blue and red lines intersect. Seems, wait, this doesn't look very logistic to me. This is wrong, isn't it? It should be leveling off at 5,000. Oh wait, is it? It does. Yeah, okay. That's so crazy how it just like suddenly bends around, like it just remembers, like it's about to be exponential and then it just suddenly flattens out. So let's zoom in on this part where they intersect, and Desmos should get the intersection point for us. There we go. So the population after, do they say what the time is in? 0.1 per year is the rate. So I guess after 10 years, our answer is that it'll be 262. I don't know how you round this number, up or down, but 262 or 263. It's Calc 2, so shouldn't it be a differential equation? That's why there was a natural log of an absolute value function. You do problems like this in Calc 2, I think, but I'm assuming that Basil's in a biology class. So yeah, if that makes sense, Basil. The other thing that I was thinking you could do is just let a calculator do this for you without even graphing it. 5,000 divided by 1 plus 49e to the minus 0.1 times 10. Yeah, you see, much appreciated? Yeah, no worries. How long does it take for this thing to get to its carrying capacity? Oh my god. Zoom out farther. Right about 140 years. Seems like a long time. But yeah, just we could absolutely derive this equation with a differential equation, but I still want to potentially confuse a person who's not expected to do that. It's an ugly plateau. It does have the curve is a little bit not visually pleasing. It's a little lopsided. I wonder if there's some like, maybe if you made this number smaller, you would have like, it would almost like a step function after long enough. No? Bigger? I guess that makes sense if it's bigger. Oh, wow, dude. That's a hell of a population growth model right there. All right, anyway. Do a couple more of these calculus problems in the meantime, or at least see if we can. No, this problem was a little bit too big to show on screen, so let's just not. All right, so in this problem, we have to take a look at the limit y equals the limit as n goes to infinity of 1 plus 1 over n to the n And for part A, we're asked to do a change of variables with x equals 1 over n. So this problem becomes, if n goes to infinity, then x goes to 0. 1 is 1, 1 over n is x, n is 1 over x. Population didn't grow, it migrated. Maybe. Natural logarithm is a continuous function. We can move it inside a limit. Use this fact along with properties. Ah. Maybe, okay, I can show just the little piece that I'm working on. So I feel like this doesn't make sense with me half-ass reading it out loud. Okay. So for part B, we take the ln of each side. And because ln is a continuous function, it can go inside of the limit. Let's not write the ln y on every step. That's going to be annoying. Ooh. These parentheses are important on the outside. Avoid a little bit of ambiguity. So with log properties, the 1 over x can come out front. So now we have 1 over 0 times ln of 1, which is 0. So we have 0 over 0. That's an indeterminate form. We can do L'Hopital's. One over 1 plus x over 1. And that we just get 1 for the limit. Oh, ln of y equals 1. Which is what was requested for that part of the problem. Since the initial function is continuous, move it inside element, use this fact. Wait. Oh. I guess I made a slight oopsie. Did I? Huh. I guess I was technically doing the limit? I guess I was, okay. Let's make my notation match. Okay, this is a little bit more form of a way that I'm used to showing it, but we definitely can. So if 1 equals limit x goes to 0 of ln y, we can also do e to the 1 equals e to the limit as x goes to 0 of ln of y. Then the exponential function is continuous, so we can bring the limit outside. And e to the ln of y just equals y. Okay, Basil is asking, also we could explain the binomial theorem and how it is used to expand binomials. Can you describe the relationship between binomial theorem and Pascal's triangle? How does Pascal's triangle assist in finding coefficients when expanding binomials? We can take 2x minus 3 to the 4 as an example. Sure. So when we do our binomial expansion, I'm going to look at like this first part of the formula that Wikipedia gives here, which is x plus y to the n. In your case, we have 2x minus 3, but that's okay. Is equal to the sum from k equals 0 to n of n choose k times x to the n minus k times y to the k. And that's weird, but it's a lot easier to know what this means when we see an example. Pascal's triangle is helpful here because we can figure out what n choose k is pretty quickly by physically comes into help here with this n choose k part of the formula. And conveniently, Wikipedia actually provides Pascal's triangle for us here. I want it to be bigger. Can I make it? Ugh. Okay, that's cool. Cool, Wikipedia. I definitely didn't want a bigger version of Pascal's triangle here. That's what she said. I want it to be bigger. Oh, that's neat. One's counting numbers, triangular numbers. Okay. Anyway. Hey, Obi. Not dead? Oh, that's good to hear. Hopefully you're feeling better. Not dead, I guess, is progress too. Okay, so our example is to expand a 2x minus 3 to the 4 using the binomial theorem. It's also fun when you extend that into higher dimensions. Oh, interesting. Had some DayQuil not branded earlier. Oh, nice. Some NyQuil not branded in a few minutes. All right, nice. So the general formula for the binomial expansion is x plus y to the n equals sigma k equals 0 to n choose k, x to the k, y to the n minus k. Let me make sure I copy that down right. Oh, I switched the exponents. I always do that. Actually, it doesn't matter. Never mind. It doesn't matter. You can do the exponent. I'm going to put it the way that I wrote it at first, actually. It doesn't actually matter the more I think about it, too, because things are symmetric. I like putting the k first. Wikipedia puts the n minus k first, and I vehemently disagree. So I'm trying to build an n-dimensional matrix in Python before I can really make any headway in some research I was doing. Oh. That's probably a better question for, like, Phobos. But in general, NumPy makes dealing with matrices a lot easier, but when things get arbitrary, then I don't know, I guess. Okay, so this is the general formula for binomial expansion, but this is the situation that we have. So that means we're going to have n is 4, x is actually 2x, and y is negative 3. So if we have 2x minus 3 to the 4th, I'll start looking into the sigma, but it's really not, this part of the problem isn't that important. Oops. K equals 0 to 4. 4 choose k. X to the k, y to the 4 minus k. But the really important part here is when we start actually expanding. And the pattern is basically going to be 4 choose 0. Oh my god. I'm sorry about that. It's not x and y. It's 2x in parentheses and negative 3 in parentheses. Ugh. Okay, so we're doing this. We're taking k equals 0. We're plugging in 0 for k all throughout here. So 4 choose 0 times 2x to the 0 times negative 3 to the 4 minus 0. And I'm writing out in painful detail here. If I was actually doing this problem just by hand for homework, I wouldn't write out every gory detail, but in case that helps you, I'm going to do that here. And we'll get to the Pascal's triangle part shortly. 4 choose 2, 2x squared, minus 3 to the 4 minus 2, plus 4 choose 3, 2x cubed, oops, not plus, minus 3 squared, plus 4 choose 4, this is the last term because we're getting to k equals 4, 2x to the 4th times negative 3 to the 0. So kind of the pattern to notice here is that one exponent starts at 0, the other one starts at the maximum, and they kind of gradually, you add one, subtract one. So we go from 0 to 1 and from 4 to 3, then we add one, subtract one again, add one, subtract one again, and they kind of, that progression keeps on happening until they're flipped. So we went from 0, 4 to 4, 0, and that's how we know we're done. That's with that part of the problem. Now we have to figure out what these chooses are, and we can quickly start making Pascal's triangle, I guess, off to the left here. So we have 1, 1, 1, 1, 2, 1. And we want to go down this list, adding, so like 1 plus 1 is 2 is the pattern. Like everything is the sum of the thing above it. We want to keep on going until we have 1, 2, 3, 4, 5 things. So we need to go down levels until we have 5 things in here. So 1 plus 2 is 3, 2 plus 1 is 3, 1. And there's always 1s on either end. So 1 plus 3 is 4, 3 plus 3 is 6, 3 plus 1 is 4, and a 1. So I think this is the floor that we want to stop on. And it should be that 4 choose 0 is 1, 4 choose 1 is 4, 4 choose 2 is 6, 4 choose 3 is 4, and 4 choose 4 is 1. I want to verify this because I'm pretty terrible with choose, but I believe that's the idea here. I did do Pascal's triangle correctly. And I'll check the other bit at the end. So 4 choose 0, I'm claiming is 1. 2x to the 0 is 1. Negative 3 to the 4, I'm just going to leave as is. 4 choose 1 is 4 times 2x times negative 3 cubed plus 4 choose 2, I'm saying is 6. 2x squared is 4x squared. Negative 3 squared. Plus now I'm on this term, 4 choose 3, I'm saying is 4 times 8x cubed times negative 3 squared. I'm doing this in a little bit weird. I don't know why I'm not squaring the 3 or actually, wait, I have squared twice, don't I? That can't be right. This should be 4 minus 1. Wait, 4 minus 3, sorry. There we go, that makes sense now. So that's negative 3 to the power of 1. 4 choose 4 is 1. 2x to the 4 is 16x to the 4th. Negative 3 to the 0 is 1. All right, so now let's keep simplifying. Negative 3 to the power of 4 is 81. Mental math. Negative 3 cubed is negative 27. Negative 27 times 8 is 160 plus 56 to 10? No, 216? Ugh, let's not do this mentally. 8 times 27, 216. There we go. And it was negative. 216x. 6 times 4 is 24, times negative 3 squared is positive 9. 24 times 9. I feel like I can do that. 25 times 9 is 225. So we subtract the 9 from that to get 216 again? Really? That feels all sorts of wrong. 24 times 9. It is 216. Okay. Uh, 4 times 8 is 32 times negative 3. We're going to get a negative answer. 32 times 3 is 96. Finally, we just have 16x to the fourth. So as much of a pain as this is, it's probably still easier than trying to use FOIL to manually multiply out that power to the 4 there. Let's verify the result that I got. But that's basically the process there. There's a lot of writing involved, but it does follow a pattern, which makes it helps out a lot with trying to use it. So we get 16x to the fourth. Let me do that. 16x to the fourth minus 96x cubed plus 216x squared minus 216x plus 81. Nailed it. Okay, so I hope that makes sense, Basil. The formula looks worse than it is. One helpful thing to notice is that, well, a couple of helpful things to notice that'll help simplify your work here is your first choose and your last choose are always 1. And there's a symmetry where the second is the same as the second to last choose. Like 4 choose 1 is 4 and 4 choose 3 is also 3. There's always that like left and right symmetry in Pascal's triangle. So like even if we go down one more level, 4 plus 1 is 5, 10, 10, 5, 1. Like you can cut it right in the middle and it's mirrored. So that symmetry you can use to kind of like simplify things a bit too. It's really confusing. Everything's been clarified. Awesome. Glad to hear it, Basil. If I'm saying that wrong, then my apologies too. I'm just guessing here. Exponential simplices are a bit hard to visualize. Oh, I bet, yeah. Okay. Get some water. Okay. Oh, I feel like I've done this problem before. Yeah, I feel like I've done this type of problem a million times. I'm gonna like give that one a pass. This half derivatives one I have never done before though, so operator h sub x acting on a function f of x said to be its half derivative applying h sub x twice gives the same result applying the derivative d sub x once. Oh gosh, okay, that makes sense. Now, I wonder if square root, I assume square root is like the metaphorical square root, not a literal square root. Or maybe like, is there like a multiplicative square root versus a different square root? Define the operator a sub x by a sub x f of x equals f of x plus pi over 4. Oh. Ha ha ha. Okay, I can see that. Oh, you need the square root of -1 for part 2? It's... feels bad. Ugh, I'm having the same problems before. Let's show the first 2 parts, because this will be quick. I haven't read part 3 yet, but... All right, so then a sub x sine of x is what they want us to think about here. So let's work from the inside out. A sub x of sine of x is equal to, well, the a sub x on the outside is still here, but then inside, this becomes sine of x plus pi over 4. And then now we do the same thing again, where we go from f of x to f of x plus pi over 4. So sine of x plus pi over 2, which, visualizing it in my head, is a left shift of sine by pi over 2, which doesn't indeed give you cosine. So then in part 2, we have b sub x f of x equals root -1, funny enough, equals f of x, or times minus pi over 4. This is going to follow the same process. We're just doing the same phase shift to the right this time, and we do need a negative in front to flip the sign. Oh, wait. We're still doing this. Oh, never mind. We're still doing the sine of x. Really? Oh, yeah. That we wouldn't go. The phase shift is going the wrong way if we were to have -1 out front. Oh my god, I wrote cosine again. So you're showing that half derivative isn't unique here? So here we're shifting sine to the right by pi over 2 and then vertically flipping it. Sine of x minus pi over 2 is the same thing as negative cosine of x. So we get just cosine of x. Boy. As we know, given any function, there's only one possible result one can get by taking its derivative. That is to say, every differential function is a unique derivative. Notice from the previous parts that the two after derivatives, a sub x sine x and b sub x sine of x, are different. What does it say about the half derivative? Oh, I just said that it's not unique. The operator isn't unique, I guess. Or there's many different ways to define the operator to get the same desired result. I think there's something deeper that I could be saying here that I'm not picking up on. But I assume that the uniqueness part was the most important part. I'm peeking down at problem 7 because I know that's going to be Feynman. Abhinav, I've looked at a problem like that before. It uses some really vague trig identity that I've never heard of. I can Google it, but I've struggled enough with these problems that I know that I just can't do it offhand. I don't get how they're going from the first line to the second line. Oh, sine 30 is just a half. Never mind, I get it. They're just evaluating that, not doing a weird identity. And they're saying that 1/2 is the same thing as 1/4 times 2. And 2 sine 10 sine 50. Oh, this is product to sum, I guess. Or it's this thing, whatever that is, I guess. Yeah, I mean, I'm sorry. These questions are just a little bit. I don't know how. Like, if you want, I can link you to this and you can have a look at it. But I'm not very good at these problems. Okay, so, well, the first thing I definitely want to try as a u sub is u equals x plus 1 to simplify the denominator right there. Du is dx. 1 over u minus 1 squared root u minus 2 over u du. I thought it'll get something a little more obvious what I should do with it now. I don't know if it's helpful. I could write this though. Just play around with it. V equals 1 over u. dv is minus 1 over u squared du. I don't know if I like this. No, I don't think that's going anywhere. CW Reaper says integration by parts. That's a thought. Yeah, the hint says to think about u substitutions, but let's try a random integration by parts and see what it looks like, I guess. So I'm thinking we derive the square root if we do integration by parts, because I don't really know how to integrate it. I think it's possible to integrate. I just don't quite know how. I gave myself a quotient rule though. Ugh. I could rewrite it. As 1 plus 1 minus 2 over x plus 1, I think, is what this would be. Yeah. So I'll be 1 over 2 root 1 minus 2 over x plus 1 times 2 over x plus 1 squared. Didn't even read the hint? Oh, yeah. No, I am curious about what integration by parts can do for us here, though. It can make the integral way more complicated, I think. I mean, maybe there's something here, but I'm looking at integrating 1 over x times 1, 2 root 1 minus 2 over x plus 1 times 2 over x plus 1 squared. That's all sorts of weird. I don't know what to do with that. Do we gain anything by multiplying the 1 over x squared inside the square root? I don't immediately see. Maybe there's some trig sub or something, but I bet you there's just a trig sub that would solve this right for us. I'm not going to plug the integral into Wolfram. Oh, Luber, do you think you might have an idea? Okay, I'm not going to go to Wolfram Alpha yet then. I wasn't going to plug the original problem into Wolfram Alpha, but I'm kind of curious, if you tried to integrate just the square root portion, what you would have there. But I'd rather not even go to Wolfram if I don't have to, so Luber, you have an idea. Definitely try it. Oh, a trick like that. Okay. Forgot about that being possible. So Lubert wants to multiply by x minus 1 over x minus 1. I know you're intending to actually, like, I mean, multiply that out, but actually, yeah, probably. Because that looks like sine or cosine, right? If we do a trig sub here. Or is it going to be like cotangent? I feel like sine or cosine should work. Let me just look at Pythagorean identities again. You tried secant. Really? Secant squared is 1 plus tangent squared. That's not what I would have expected to try. Is secant theta, like, promising? Because I'm thinking, like, we have x squared minus 1 in that denominator. And for secant squared, we get tangent squared plus 1. I don't like doubting Looper, though. Do you still get a Pythagorean identity with secant? Or, like, do you get some other identity that's helpful somewhere else? Oh, maybe. Ooh. Okay. Let's try it and investigate, because maybe even if the denominator doesn't give us Pythagorean identity, the numerator might come in handy still. Oops, not you. I bet we want to multiply out the numerator. Not 1 over. It does not get flipped. Okay. Should take care of that denominator since secant squared minus 1 is tangent squared. Oh, wait, was I not? Oh, I wasn't rearranging it right. Oops. Yeah, you're right. It is tangent squared. Ah, okay, okay. I was completely misreading the... I don't know. I just can't, I'm for some reason just terrible with those Pythagorean identities. Like, they should be really easy to know and manipulate, but I have like a mental block with them. Secant theta minus 1 squared. Okay. So secant theta cancels with secant theta partially. Tangent theta over secant theta. That's probably just sine, isn't it? Sine over cosine times cosine. Yeah. Do the next step. This becomes secant theta minus 1 over tangent theta. Oh, probably want to keep. Well, probably don't want to do that cancellation yet, do we? Because now this is much nicer. Tangent thetas cancel. We get 1 minus cosine theta. Wow. That's kind of crazy. Wait, we have to unsub, but that cleans up really nicely. Good spot on that, Lubert. Oh wait, arcsecant. Simplify that. Arcsecant is hypotenuse over adjacent. So sine of this thing, okay. Like that. I think is my final answer. Let's verify it though. What? Uh, huh. That looks got a different answer entirely. Oh, right, yeah. Okay. Sorry, I just realized that I just understood part of what Luber said about canceling the numerator and the radical way earlier. Now, this could somehow be equivalent to what I got. Let's take the derivative of my answer. It's probably not equivalent, but let's just... verify. I'll get a common denominator, Wolfram. This does match, doesn't it? This is the original problem. So I think I got the right answer. Let me see if Fenbox's answer is right. Because arcsine might have some weird relationship with arcsecant like that, with the 1 over on the inside. If you take off one of these x's and bring it inside the square root, I think it matches. Yeah. So I think you're right too, Fembox. Yeah, this is a little closer to how we have it phrased initially. You would have to take, you have to do like, take this x minus 1 on top, square it and square root it, and group it with this square root, and then cancel the x minus 1 factors. But if you do that, then they're the same. Now that leads me to the other thing I want to see, which is arcsine 1 over x. Arcsecant x. I feel like we've investigated this before. They are nearly the same thing, though, just translated a bit. There we go. Hey, Suna. Oh god, this is the Feynman problem. At least for the downtime for today, I've been going through this. It's from Dr. Cook, who's a regular, but he has just like a PDF called like bonus calculus problems easier that I've been going through. So there are a couple of like relatively simple limits that they did involve tricks. Doing the limit definition of E. I skipped 4 because I feel like I've done it before. Half derivatives, which I've heard of, but I've usually avoided. Yeah, it's kind of like just a bunch of miscellaneous calculus problems. Alia over on YouTube. Oh, well, thank you so much for the kind words. Hope you have a good day too. Easier? Yeah, the easier version has Feynman's. The hard version is over here. I haven't even looked at it very closely yet. This looks, oh my god. You are disgusting. I'm sorry, integral, but it has to be said. Okay. This will be for another day. This one? Can do that in 30 minutes? Okay. I probably just need to figure out the trick, but that looks like it seems like something about pi over like a geometric mean or something like that. Crunch time, 4 days and 5 hours at least. I don't know. I won't be for another day. The downside of being an optimist. You know, I believe in you, Suna. If you do that in 30 minutes, or really in any amount of time, I'll be cheering for you. Ah, computer guy, hey, how are you? Nice to have you here. No worries. Well, number one is kind of done for you here, I guess. Show that df dx is equal. Okay. This is going to be a little bit too big to show while I'm at the whiteboard. This might be the problem. I think I have enough energy to go through this problem, but we might wrap it up after it. An actual, yeah, it's going to be a little bit of a pain. Just like have around and keep clean, but I do love the vibe of a whiteboard. Okay, so the derivative of a to the x minus 1 over ln a, well, the 1's going to go away. The a to the x derives to a to the x ln a, which is going to cancel with the denominator. So I think we just get a to the x, right? And the integral of a to the x is going to be a to the x times ln a? No, divided by ln a. From 0 to 1? Differentiate, yeah. This isn't right, so is it? I'm getting things... No, this isn't right. What did I mess up? I'm definitely not getting 1 over 1 plus x. Okay, stupid question for Wolfram alpha. 2 to the x derivative. 2 to the x times ln 2. Okay, so I did do that part right. Oh, do you like follow Computer Guy? I just followed you because Stuki shouted you out, to be honest, because they always know great streamers, so. If you're streaming follow, I'm definitely gonna have to catch a stream. Oh, okay. Well, that's fair enough. Sorry, I'm like I'm like mostly focused on the problem. So if the joke is like I'm not like getting it, that's why it's because I'm half distracted. Got the most content on YouTube. Oh, okay, neat. Is this a weird like we can treat a as a constant when we take this derivative, can't we? Maybe we don't have to worry like a partial versus total derivative, I don't think. Oh, wait. I see the issue. Yeah, Bluebird. I integrated with respect to x, not with respect to a. This is a power rule, not an exponent rule. We get a to the x plus 1 over x plus 1. For a equals 0 to a equals 1. So we get just 1 over x plus 1. Okay, that makes sense. Integrate, and this thing is equal to df dx. Integrate the previous result with respect to x to show that f of x is equal to ln x plus 1. Oh, Dr. Cook does not include the absolute value bars. Well, I mean, do we know something is positive here? I guess, I don't know. I just like being a jerk. So we know what f of x is. How are we going to use this? Use the fact that f of x equals 0 is equal to 1 minus 1 ln ADA is equal to 0 to find the constant c. Right. Go back to the integral definition. So f of 0 is 0, which means f of 0 equals ln 0 plus 1 plus c. C equals 0? Aren't I supposed to get 1? No? Okay, he doesn't say what we're supposed to get. Calculate f of 1, the original value of the integral. Ln of 2. So I was playing Fallout 4 like an RPG, not talk much with chat and act like you were actually the player. Oh, interesting. Taking the RPG part of the game seriously. Did talk with chat. And then just be my silly self on setting. Oh, that's nice. I like that style. Is there a way that I can check? What if I should do it numerically if it can't do it directly, right? I can compare with what ln of 2 is. I did an indefinite. Ugh. Hey, ln2, let's go. First time I think I've actually done Feynman integration rather than just looking at it being done for me. Although this is pretty like you are like spoon-fed each of the steps, which I definitely needed. Yeah, I don't think we're going to do it today, but problem A is about the gamma function. Problem 9 is about Laplace transforms. Which is unfortunate where we don't actually solve a differential equation with it. But we just play with the deriving it. Hey, Grim Reaper. No, I'm not currently a student. This is just doing math for fun, if that's believable. The theme of the stream is that I take like homework help questions from people in chat, but if there's like a slow time like there is now, I just kind of do whatever random studying I feel like. So I'm not currently studying, like I said, but I want to like stay sharp and try to learn new things. So these are some kind of like challenged calculus problems, I would call them. So we were just doing one on a pretty neat integration technique called Feynman integration. And unfortunately, I was going to wrap the shrimp in a couple of minutes, but I was kind of like looking at what else is on this worksheet. So yeah, talk about the gamma function, the Laplace transform, and proving that E is irrational. Oh god, there's so many things here. Oh, okay. I mean, I bet I can do this. It just will take a lot of writing. But yeah, Grim Reaper, anyone who might be like new around in chat, might be lurking. I'm not the only math streamer out there. I just like to periodically shout them out. All people on that list do math help in some form. There's like there are like different styles of help, or some people will, or different styles of streams, where some people have a mix of gaming streams and math streams. Some people purely do math. Some people only do games and switch to math if someone asks a question, but everyone on that list does math help in some way. trying to stay sharp for my Calc 1 class myself, econ major. I know math's important. Ooh, nice. Yeah, I know very little about economics or like about like math for economics. But there are some like neat little things with it from a little bit that I do know. Yeah, you wouldn't have to do probably much any of the stuff that we're talking about here for econ. It is fun though. What's up, Critical? I'm gonna wrap things up since it's probably gonna be the last one. Hey, Bubble Short, give me an indefinite and integral by parts example. I'll do you one better. I'll give you a website with a bunch of them. Paul's Online Notes is my favorite website for everything calculus. They don't go much into the theory, which I actually personally like. They just give you the information that you need to get through a calculus class. Paul's Online Notes, yep. So this is the link to the site, and what I would do, just scroll down. They explain how to do it, but like all the problems on this page are going to be integration by parts. So like I would take this one as maybe like your first example, and then once you think you've done it, hit show solution, and it'll walk through step by step. About a website about solving the Riemann hypothesis. Unfortunately, Paul's Notes doesn't go that far in. Yeah, no worries. So there's a couple of examples on this page that show a bunch of different like tricks. And then if you want even more, there's practice problems. And even assignment problems. I don't think that they provide solutions, but you can always use Wolfram Alpha to verify your solutions. So yeah, this will have a bunch, and it'll take care of, it should take care of basically any integration by parts trick that you might need to know. Do they show like, yeah, okay, this is an important trick to know. Yeah, no worries, Bulbasaur. Also, I love the name. This is problem from Critical. Recite when you need my calc class. Oh man, it helped me out a lot with getting through my calc class. Keep forgetting how to do these. Okay, yeah, I mean, this is basically a couple of calculus 1 problems smashed together. Yeah, chain rule, product rule. You know, before I forget, I do want to promote one little thing, which is in 2e to the 2I pi. There we go. In just under 3 hours, like 2 hours and 50 minutes, Zach, or e to 2I pi, like I put in chat, is going to be doing, or this it's going to be the continuation of the second week of a real analysis class that he that's being taught like live on Twitch, and you can participate either in voice chat as part of the group, or you can be in Twitch chat and just kind of lurk, or you can even just watch the VODs. But I just want to give that a little shout out. Grim Reaper, thank you for the follow. Yeah, I've done rubbing alcohol once, and I have like spray this, or like a, I have like the I have this exo spray too. It's not too good for like the really stubborn smudges, but the rubbing alcohol seems to work okay. Windex I hadn't heard of, but that sounds like it would work. Okay. Show me was like magic. Oh, yeah. Okay, so we just need the derivative. It should say with respect to t, but they don't. But we'll take it with respect to t. So let me just do this separately. For the first part, we want to find d by dt of sine squared of a t. I guess we can include the I vector, but it's just a constant that's being multiplied, so it's not going to affect anything. The real important business is what to do with sine squared of at. So for the sake of chain rule, I'm just going to really like draw it out. I wouldn't normally write it like this, but I'm going to write this as sine of at in parentheses squared times I, because that makes us having the chain rule a little bit more clear. Sometimes the squared being there, it's easier to write, but it makes the chain rule a little bit weirder to see. So when I do the chain rule here, I'm going to work from the outside function in. So we have to figure out what to do with the squared, what to do with the sine, and what to do with an a times t. So first off, if we have anything squared, we apply the power rule. So the 2 comes out front, and we subtract 1 from the power. So 2 times whatever we had inside, sine of at. And then this would be to the power of 1, but who cares about a power of 1? So that's the outside function. Now work one level in. We have to take the derivative of sine, which is, ooh, this looks really confusing. I'm going to get rid of the power of 1 because it looks like a prime, and it's not. So now we're taking the derivative of sine, so we get cosine, and then we had the at on the inside, so we just keep the at on the inside. And finally, the last function on the very inside is at. At, we just treat a as a constant, so it derives down to just a. So cleaning it up a little bit, we get 2a sine at cosine at. Oh, I dropped the I vector. I don't know why I'm putting times I, but that's the first piece of the puzzle. Second piece of the puzzle. Let's figure out, oh, this is a little bit too, never mind. I need to put the green ink in the marker. Just number it. 1, 2, oh my god, that's a terrible bracket. I can't live with that bracket being that terrible. So 1, 2, d by dt, t e to the bt j. So again, the j is just a constant multiple, who cares? I have a question. Where in the fuck are the numbers? There's a 2 in there, you know, that's a number. You're right, there are almost no numbers here, though. Hey, Country Tyler. Okay, so when we take the derivative of this thing here, it's a product rule, because we have t times e to the bt. So when we do the product rule, I'm going to take the first part of the function, take its derivative, t goes to 1, times the original part of the other, so e to the bt. Now we keep the first one the same, t, and take the derivative of e to the bt, times b e to the bt, and that j just kind of stays there. Bubbleshore, thank you for the follow. Man is a genius. The best math happens after the numbers go to bed. Yeah. Math gets a lot cooler. when you get to not worry about the exact numbers. All right, so now this is our answer, but we can clean it up if we want. E to the bt plus bt e to the bt j, and that's how I like it. You could factor the e to the bt out. It doesn't really change anything though. It's the second piece of the puzzle. Third piece of the puzzle, cosine squared ct. All right, this is the exact same procedure as with sine squared of at. So I'm just going to start working on the chain rule. So the squared is our outside function. If you have something squared, when you derive it, it goes to 2 times whatever that thing is to the power of 1. So 2 cosine of ct is the first part. Now work our way inside by one function. We have cosine of ct. Wait. No, I'm good. I do that later. Cosine of ct becomes minus sine of ct. Work our way in one more function to ct. That becomes just c. And the k is still on the outside here. Clean this up. The minus goes to the outside. The c goes to the front. Sine ct cosine ct. So then the final thing is minus 2c sine ct cosine ct k. Of course, forget the k there. Oh. I'm deriving a formula for what happens when you differentiate. I personally don't like labeling them like that. If it works for you, then I'll show you how to do that too, but this problem is weird to do that labeling thing with because we have three layers of functions to worry about, not just 2, and that's where that kind of falls down. If we want the derivative, say sine squared at, just to go back to this example, what we can do is say that f of t is t squared, because that's our outside function. Just take whatever we have and square it. And that g of t is equal to sine of at. But the issue is we still have the sine of at, so I'm kind of glazing over that part. But we could do this, like, so we could say that g prime of t is cosine at times a, but I just did a chain rule right there. So it's kind of like we need another layer of, like we need an h function to make this labeling thing work, which is why I don't quite like it. But if we were to do it like this, we know that f, d by dt, oh, actually, I'm sorry, so I should back up. I named the functions like this because f of g is sine of at squared. So if we want d by dt of f of g of t, that is f prime of g times g prime of t. I didn't find f prime, did I? F prime of t is equal to 2t. So now we have all the pieces we need to plug into the right-hand side. So f prime of g, so we have 2 times whatever, 2 times t, but in our case it's g of t, so it's 2 sine at. And then times g prime t, which is cosine at times a. And that does match. So I guess that's how you could label it. Oh no, you're right. It's my bad about forgetting about the problem being in the way. Okay. No worries. All right, we're probably gonna wrap things up here. No worries, critical. Just seeing if there's any like friends of the stream who are on. If not, I might just have to shoot you all out the airlock. More text that Penny's using at all? Not really, no. Is it good? I assume it is because I really love the Purcell and more in one. Fx is e to the bt or be to the bt. F of x is just e to the bt. F prime x will become be to the bt. Correct. Or I would say f of t rather than f of x, but other than that, right. Oh, is this a person? I recognize this person's name. I don't think I've watched their stream before, though. Okay. I'm gonna cut the YouTube stream off here. So if you're on YouTube, thank you. Yeah.